Hey everyone, welcome. Thanks for joining me. For those of you who are celebrating Thanksgiving in the US and other places, hope it's quiet. Hope it's quiet before the storm that is Black Friday and Cyber Monday. As we get started, as we let a few people join, I'm going to go ahead and jump in here, but love to hear where you're joining from. So if you wouldn't mind, take a minute, drop in the chat, tell me where you're coming from. Just love to get a feel for where everyone is tuning in from. All right, with that, let's go ahead and get started. I'm going to give a quick introduction of myself, just for those of you who don't know me or who haven't been part of these sessions in the past. I'm going to go ahead and just give a brief introduction, just so you know who I am. So I'm Chad Butler. I spent the last 24 years plus in security, doing everything from working as a systems administrator to a pen tester. Spent a lot of time as an AppSec engineer, and then about the last 10 years of my corporate career was in security leadership positions. Built 5 programs from ground zero, from scratch to scale, and most of those were in the product security space. The only one that wasn't, well, I guess it still was, but when I worked at Amazon, I spent some time at AWS doing product security leadership there, and then I moved over to the Amazon Prime Air team, where I built and led the cybersecurity program for the drone delivery program. And that had some really cool experiences through that. Had the opportunity to teach for SANS in kind of some community level courses and mentoring aspects. Really loved the training aspect. And so about a year and a half, almost 2 years ago, I left the corporate world, started my own company called Mission InfoSec. And with that, I do some product security consulting, but I also do 2 courses, which is really my passion. Teaching is always what I've enjoyed. One of those is a free offering called Career Hacking Quest, and that is specifically for people who are looking for jobs, primarily in the cybersecurity space, although I think it is applicable to others in the tech industry as well. That's free, and with that I do bi-weekly resume review sessions where I give feedback and just kind of get into the shoes of a hiring manager. And that whole course, the community and the bi-weekly resume review sessions are to help people understand what happens behind the scenes in the recruiting space so that they know how best to approach their job search. And then I also do DevSecOps Pro. And this kind of came out of my strong feeling that there's some great training out there, but most of it is really, really expensive. And so I wanted to create something that was SANS quality, but also affordable for self-funded students. So that's what DevSecOps Pro is all about. It goes a little bit deeper than what we're going to do today. It goes a lot deeper than what we're going to do today. And I've got a surprise special bonus for those who stick with me till the end. All right, so let's go ahead and jump in. This is the third part of a 3-series webinar. And it's all about creating, kind of getting AI ready. You know, we're moving more and more code development, application development is being done by AI coding agents. And so we've been talking about what does that mean? How do we build for that? How do we adjust for that? And how do we build the skills needed to be competitive and effective in the future? And so the first webinar was the AppSec Impact Framework. And this is kind of my collection of 24 years of doing this. What are the things that I've seen really work and what are the things that I've seen don't work? And I kind of encompass that, and you'll see that in just a few slides here. The next one, which was on Monday, was the 4-layer AppSec automation stack. And we talked about how to build automations. I introduced some of the free and open source tools that I really love and use in my day-to-day AppSec work. And then today we're going to go through, this is the culmination, and I'm really excited about this. We're going to do a live demo and we're going to build one of these GitHub actions live, and you can follow along. So a couple things. First of all, if you missed the first 2, I'll have my team drop a link to the replays. You can find those on my YouTube channel, but I'll have my team drop a link in the chat for those of you who want to go back and watch those later. And then finally, if you want to follow along, you're going to need a GitHub account. They're free. So if you have one already, you're good to go. Just use that GitHub account. If you don't have one, while I'm kind of setting this up, I recommend going over to github.com, sign up for a free account, and then you'll be ready to go when we start doing the build here in just a second. Okay, one of the questions I often get, or that you often hear, is, can I get a copy of your slides? Yes. The easiest way to do that is to register for this webinar series. So at the end of this webinar today, you'll get an email that has a copy of the slides. It's going to have links and all the materials that I promised. And then you'll also get a certificate of completion. Now, it's the last part of November, the year is winding down, and so probably a lot of you are doing what I did for many years, which is collecting certificates of completion for continuing education credits for various certifications that you hold. If you need that, you'll get that by default just by registering. Like I said, about an hour after we complete here, you'll get that email and you'll get the certificate of completion, the email with the slide deck and all the links and stuff that we share, as well as certificate of completion right after. So if you need that or want that, feel free to register and you'll get that automatically. Okay, so the agenda for today, we're going to go through a very brief overview of GitHub Actions. This is going to be surface level, just enough so that it makes sense what we're talking about as we go here. I'm not going to spend a ton of time on the theory. Just know that if you would like that, there's options. My DevSecOps Pro course goes into that in greater detail, but I'm going to give you just enough so that it makes sense. And then we'll do the live build. And then after the live build, and in that live build, we're going to build a GitHub Action workflow that creates an SBOM for your repository. Now, let me just quickly say, if you're not in product security or application security, this is still a really helpful skill to have. There is so many things that you can do with GitHub Actions that make your life easier. For instance, one of the things that I share in the course is, you can't secure what you don't know about, right? If you don't have a good inventory, if you can't see what you're trying to secure, it's really hard to do it right. And so one of the things I talk about is how you can use a GitHub Action workflow to build out an application inventory, to collect things like risk information, to find out, if your applications are highly risky or not so risky, and to do that automatically with a GitHub Action workflow, and then to keep that up to date. So there's a lot you can do here, and this really sets the foundation or builds the foundation for you. Then we're going to talk about how, the scaling path, how you can use these GitHub Actions to scale, and it's, spoiler alert, automation is the future, and you're going to be learning that today. And then we'll close the loop with how that impacts us from an AI perspective, AI coding perspective, and then we'll wrap up. And as I said, I've got a surprise bonus at the end, so hopefully you stick with me. Okay, so if you've been with me through the previous two webinars, you would have seen the AppSec Impact Framework at this point. And again, this is, as I looked at the programs that I built and the programs I've been involved with over the course of my career, this is a collection of the things that I found either work or don't work, and these are the things that work, the things that I feel are important as you approach product security or application security to build trust, to build rapport and integrate with those teams. And so today, the most important aspects we're talking about here are the integrate component, the collaborate, and the trigger component. So we're going to go pretty deep on those. So let's go ahead and jump in. Okay, so GitHub Actions. Why do we even care about GitHub Actions? Why do we care about GitHub? First of all, it's the automation. It's that path of least resistance, right? We want to automate these security tasks so that we don't rely on some human being having the thought or the best intentions, remembering to do the thing that we promised to do or that we know is important. We don't want to have to rely on a human being to do those all the time. Humans are important, and humans are going to be in the loop, but we don't want to have to rely on them to remember to do the thing that we need to do. Also, GitHub, it really is the path of least resistance. If you remember from the first webinar, I talked about don't force developers to come to you. You want to go to them. And GitHub is by a pretty wide margin the most popular platform for developers. 100 million plus developers, 4 million organizations are using it, and it's got a lot of tools that you can use. So in addition to like pull requests and actually storing your code and being able to tell who changed what, it's got the functionality for code reviews, issues. So instead of using Jira, you can actually create issues in GitHub. project boards, wikis, notifications, like all of those things are there in GitHub. And so GitHub has done a really good job of developing this platform that allows developers to do their job. And so you'll find, as I did, that a lot of developers spend the majority of their day in GitHub doing the things that they need to do. There's also a strong marketplace, a lot of pre-built actions that you can just use and leverage. A lot of the security tools that we talked about on Monday have pre-built GitHub actions that you can just drop in and have them work. And then there's also great community support. Also, so if you're not using GitHub, chances are your developers are using something like GitLab or Azure DevOps or something else to build out these workflows and do these things. The principles are the same. You're going to use the same principles. The vocabulary, the technical implementation details, the syntax, those things may change, but that's the least significant detail. Once you know how to do something, frankly, if it were me and I was building out something in GitLab, I would go to AI and be like, hey, I've got this GitHub action. I want to build this out in GitLab or Azure DevOps. How do I do that? And I would just allow AI to do the heavy lifting of telling me what I need to build. Again, once you've got the foundation and the principles right, the syntax and the vocabulary that's used is the less significant. Okay, so let me quickly go through the anatomy of a GitHub action, just so you understand what you'll be looking at. And again, if you can read a configuration file, you'll do just fine with this. It's not rocket science by any means. It's pretty straightforward once you understand the basics. So first of all, you'll see over on the right, there's a kind of a hello world GitHub action. That blue box is the workflow. So the workflow is just an automated process, and that is, in the context of GitHub, that's an actual .yaml file. So that's the file where all of your configuration for this workflow exists. And in GitHub, if you've got workflows in your repository, there will be a special directory named .github. And within that directory will be an actions directory. And that's where all of your actions live, your workflows. So when we say a GitHub action, we're talking about a workflow. And at the basic level, we're talking about a .yaml file that lives in that directory in your GitHub repository. Then the next layer down, and so actually you see it's got a name. And so you'll see that as you go through and debug things. That's the name that's going to show up in your debug logs. It's going to tell you, or it's going to define when it's going to run. So in this case, the on keyword says we're going to run on all push actions. So whenever a developer pushes code, we're going to run. And then we can further filter that by the branch. So in this case, we're filtering it so that it's only going to run whenever a developer pushes code to the branch named master. And you can, and that can be an array, that can be any number of branches that you want to control. You're going to also have it run on schedule, and we'll see that in a minute, where you can give it kind of a cron syntax so that it'll run periodically on a scheduled basis. And then that workflow dispatch keyword there that's a special keyword which is used to designate that I should be able to run this ad hoc. So I should be able to kick this off manually. I pretty much always add that just because, especially when you're doing troubleshooting, a lot of times you'll want to make a change, run it manually, and see how it works. Okay. Next layer down is the job, and that's the purple box on the right. And a job it's a distinct section of that workflow. It's a job, right? And what's important to understand here is jobs run in parallel by default. So let me back up a little bit. These jobs are going to be sent to GitHub runners. Now, you may be asking yourself, what is a GitHub runner? A GitHub runner is basically just a virtual machine running in GitHub's cloud somewhere. And so if you look up above, or actually not above, if you look in that job section, it says runs on. So this is going to run on a GitHub runner that's running the latest version of Ubuntu Linux. And so it's going to send that out to a GitHub runner, and it's going to execute whatever steps are in that job. So why do we care that these are ran in parallel by default? Well, this is a very simple workflow. It's just got a single job. More complex workflows may have several jobs, and some jobs may depend on the output or what's done in a previous job. And so if you don't know that these are run in parallel, you may not understand why that subsequent or later job doesn't get the context that's needed from the earlier job. And that's because it's running on a different GitHub runner. So if you need that, you need to be aware of that. And I don't go into that here, but that's something that if you want more details on, you can Google the docs, or my DevSecOps Pro course goes into that in a little bit more detail. So just know that they run in parallel, and that those are going to be forked out or farmed out to a GitHub runner. And then you have the steps. So these are just the individual tasks, and within those tasks are the individual commands or the actions. And this is a point of confusion for a lot of people. When we talk about a GitHub action, capital A, we're talking about the workflow. When we talk about actions, lowercase a, we're talking about the standalone commands or the individual commands that are run within those steps. So in this case, if you read this from top to bottom, we've got this GitHub action. It's named Hello World. It's going to run on all pushes to the master branch. It's also going to allow you to run it manually. And then it's got a single job that's named Say Hello, or that is named Print Hello World. It's going to run on the latest version of Ubuntu Linux in a GitHub runner. And then it's got one step that's going to say hello. It's named Say Hello. And all it's going to do is run the command echo hello world. And so that's really all there is to these things. And you can combine all of these concepts into very complex tasks and workflows that do really incredible things and interesting things. The one thing I will point out here is white space matters. So these are YAML files. So indentation matters. Tabs and spaces and all that matter. And you'll see in just a minute as we build this out, if you build this in GitHub, it will help you with a lot of that syntax, and it'll highlight issues that come up. Okay, so with that, let me actually just pause real quick to make sure there aren't any questions. If you do have any questions, please drop them in the chat, and I'll try to look at them from time to time, but I'll definitely take time at the end to make sure that we cover those. Okay, so let's go ahead and jump in. So we are going to build out an SBOM using the CDX Gen utility. And this is a utility that builds a Cyclone DX SBOM. So in the last webinar, we talked about the different SBOM types and formats. And to just a brief TLDR, Cyclone DX is the only one of the three major SBOM formats that includes security details by default. And so that's the one we're going to use. Again, if you want to go back and watch that, there are some caveats to that. There is the SPDX format, which actually has an extension that you can load that will allow you to do security details in there, but it's not the default, unfortunately. I do have a YouTube video on that if you're interested in digging into the various SBOM formats more, and I'll have my team drop that link in the channel, in the chat. Okay, so we've got a few objectives here. Create an automated workflow. We wanted to generate the SBOM, and we wanted to generate an SBOM artifact. And we want to be able to download that and use it for whatever we need. We're going to make it available to download from GitHub, but you can just as easily push this into some other framework or tool that you're using to manage your SBOMs. So tools like Guac or Dependency Tracker from OWASP, you can push these directly into those platforms. And then the last thing we're going to do is analyze that SBOM file using a tool that we introduced in the last webinar called OSV Scanner. So let's go ahead and jump in. I'm going to switch screens here. So if you've got your GitHub account, make sure you're logged in. And what I want you to do is just search for the Juice Shop repository. And so this is from OWASP, and it's a deliberately insecure application that we're going to use. So, and I'll have my team drop a link in the chat just so if you can't find it. We're going to go to that repository. And the first thing we're going to do is fork this repository into our GitHub account. That's going to allow us to do whatever we want to do with it without affecting the upstream repository. So I'm going to go over here to the fork section, click this down arrow, and create a new fork. So you can see that this is going to create it in my account. I'm the owner. I can name it whatever I want. So I'm just going to tack on something at the end here, and I'm going to go ahead and create fork. That'll take just a couple of seconds, and then that will end up in my account. So you can see, if I look up at the URL, this is in my account, and it's a fork of the repository. So this will kind of stay. This will help you understand, whether or not you're in sync with the upstream. So currently we're up to date, which is expected because we just forked it. And so as the upstream continues to change, we'll see that get out of sync, or as we make changes, we'll see that get out of sync. But you don't need to worry about that right now. Okay, so the first thing I want to do is show you, remember I said that the GitHub actions live in this special directory called .github. So if we open that up, you'll see there's this workflows directory. And you'll see that there's actually quite a few workflows that have already been built by the package maintainers. And you can actually look at some of those and check that out if you want to. But for now, I want to actually get rid of that directory. So I'm going to go ahead and delete, actually I want to delete the workflows directory. And the reason I want to do this is because, so I'm going to click delete, click commit changes, and then I'll commit that to the master branch. The reason I want to do that is as I go through and create my GitHub workflows, it's going to add to that. But these are workflows that were created by someone else, and they're going to be running within my repository that I've forked. And so if you don't understand those, it's you either need to review them and make sure you're comfortable with what they're doing, or you need to delete them and start from scratch. I just want to delete them. Also, it's going to cause issues because every time we commit to the repository, it's going to kick those off, and it's going to cause additional wait time. Okay, so now that we've done that, the very next thing that I want to do is I'm going to create, I'm going to go to the Actions tab first of all, and I'm going to create my action workflow. So as I said before, there's a great marketplace here available, and so when you have a minute, just try this out. Search for security and see all of the different things that come up here. There's some great workflows available, again, that you can just drop into your repository and use those tools that are available. Some of them are free, some of them require a commercial license to use the tool that you're using or whatever, but there's a lot out there. We're going to choose set up a workflow yourself because I want to build this from scratch and show you how that works. Okay, so go ahead and click set up workflow yourself. And now that that's here, I'm going to name that something, let's just say cdx gen-SBOM. I cannot type. Okay, first thing we're going to do is give it a name. Now, before I jump into this, I'm going to show you really quick. I've actually created the answer key, if you will. Everything is here in this repository. I'll have my team drop a link in the chat. So if you don't want to type this, you can copy and paste. It's what I'm going to be doing just to make sure that I don't make a typo live here. Okay, so the first thing we're going to do is give it a name. And so I'll drop that in there. And then once you've done that, you're going to give it, you're going to tell it when you want it to run. So remember that hello world workflow that we just saw. It was scheduled to run whenever we have a push against any push to this repository filtered to the branches in this list, which is only master at this point. So we can go ahead and do that. Now we can also do a schedule. So remember I mentioned that you can use a schedule to kind of use cron syntax in order to make this run whenever you want it to. So let's just say we want this to run weekly in addition to whenever pushes are, or whenever code is pushed to the master branch. So we use this cron syntax. It's the same syntax. If you're used to cron, you're used to this syntax. What's really kind of interesting here is you can hover over that and it'll tell you exactly when it's going to run. So in this case, 7:45 on Thursdays. And if you want that to run more frequently or less frequently, you can tweak that. Just note this comment here that it's only going to run at most every 5 minutes. So you can't get it to run more frequently than every five minutes. Hopefully you're not having to do that. And then finally, remember there's that workflow dispatch. And this is that special tag that says, allow me to run this or kick it off manually. Again, I kind of run it. I kind of always add that just because I want to be able to do that. I want to be able to kick things off manually when I am troubleshooting. Now, I'm not going to go into this part too much, but we do need to give our workflow some permissions. So in this case, we're gonna allow it read permission, and this is simply because in order to do this, we need to get a copy of our repository onto that GitHub runner so that it can run cdxgen and generate the SBOM. So we'll go ahead and do that, and then we will first build out our jobs. So let's go ahead and paste that in there. So we're going to call this build-sbom, and then we're going to tell it I want this to run on the latest version of Ubuntu. So as it sends this out to a GitHub runner, it's only going to use a runner that's running the latest version of Ubuntu. Okay, next as I said, we need to get a copy of the code, and so the first step in this is to check out the code. And so there's a GitHub action that's called checkout. And so if you look here, actions, these are typically, these are actions that are coming from GitHub. So they're very common things like checkout. And we're going to use another one in just a minute called upload artifact. These are coming from GitHub, and we're telling it to use v4 or version 4. And it'll use that action to complete this step, which is checking out the code on that GitHub runner machine so that we can do what we need to do. Now, let me take a quick aside here. There have been a lot of issues in the software supply chain space lately. There have been specific issues, if you recall the TJ Actions worm, where malicious actors were able to compromise well-known and widely used GitHub actions, third-party GitHub actions, to do malicious things within a user's GitHub action or GitHub repository. The reason that was made possible is because of this version string. So I'm using @v4. That's a semantic version. It means that somewhere, so in this repository, so there's if you go to this repository, there's a GitHub repository for this GitHub action, checkout action. Somebody somewhere has said, or the developers of that action have said, I'm going to tag this specific version to v4. And with that, there's a hash, a secure hash that's generated, a SHA hash, that says v4 is mapped to this specific commit that's represented by this specific hash. And what has happened in some cases is that malicious actors have taken control of GitHub developers' accounts and been able to introduce a new commit that is malicious and then remap that tag to the malicious commit. So in this case, if somebody was able to compromise GitHub's account and then they modified or they committed a new version of the checkout workflow or action, they could then remap version 4 to a different commit, to their commit. And now because you're referring to this by tag, this semantic version, you automatically get their malicious commit. So the thing to do here is to use the commit hash. So instead of using v4, you use the commit hash. I've got a YouTube video where I explain exactly how to do this. I'll ask my team to drop that link in the chat. I'm not going to do that here. It takes a little bit of time to do it, but please, please, please get in the habit of always using those. Do as I say, not as I do in this case, right? But we're going to go ahead and keep moving here, but just know that this v4, if you type in or if you copy and paste in the hash for that v4 commit, it'll always refer to that commit, which means that somebody can't slip in a malicious commit to you. Now that also assumes that you're reviewing this code, so you really should review these GitHub actions before you use them. And I've created some content about how you can do that, how you can use AI to kind of review those things. Again, it's well beyond the scope of what we're doing today, but just know that that's out there. Okay, so we're going to check out that code. And then the next thing we're going to do is just to create a specific directory for those reports to live in. So remember, we're going to create that SBOM artifact, and I'm going to drop that into this directory called reports on that GitHub runner. Okay, so next up, this is where kind of the rubber meets the road. We're going to generate that CDXGen, or we're going to kick off that CDXGen scan. So let me break this down a little bit. We're not going to go through this with every detail, but so we're calling this generate SBOM, cyclone.dx in JSON, and then we're running this command. So very first, we're going to create that reports directory, and then we're going to run a Docker image. So this is we're using this cyclone.dx CDXGen Docker image to do everything that we're going to do. And so everything that comes next is basically saying, hey, we're going to use this GitHub runner user account to run these things. We're defining our home. We're defining where the NPM cache sits and all of those things. So you don't need to worry too much about all of these details. You can obviously Google these and figure out what it does. But the most important part is that we're running this Docker image in order to create this, and we're going to drop this in this directory here. That's this sbom.cdx.json file is going to be what we want to do, or what we want to collect. Now I'm going to make one small change here, and this is something that you don't have to do, probably shouldn't do, honestly, but I'm going to tell this to not download the dependencies, which you would never do in this case. But the difference is, in my testing, if I run this with the dependencies, it's going to go out and it's going to run npm, and it takes about 6 minutes just to pull in all of these dependencies. So by not pulling in the dependencies, I can run this in about 2 minutes as opposed to 8 minutes. And so I'm going to do that just so that you can see it actually finish without having to wait around and twiddle our thumbs for 8 minutes. Okay, and then the very last step we're going to do, so now we've got that SBOM created. It's going to drop it into that directory. Now we want to upload it so we can get it from GitHub. So we're going to create another step that is called upload SBOM artifact, and we're using another GitHub action that's called upload artifact. Again, we're pinning it to version 4. A reminder, don't do this. Pin it to the commit hash after you've reviewed it and made sure it's safe. And then we're going to give it some parameters. So we're going to call it CDX SBOM. This is our path, and we're going to retain those files for 30 days. You can put that to be whatever you want. Maybe you want it for 5 days. So I'm going to change it. Do whatever you want there. It's going to take a little bit of storage in your GitHub repository and your GitHub account, but you'll know hopefully what you need that to be. So now that's created, and if I look through here, like let's say I accidentally mess something up, you'll get little squiggly lines similar to what you would see in an IDE when you've got a syntax error. This one isn't telling us a syntax error, but if you see a squiggly line there, make sure to figure that out and adjust that. One thing that I've seen before is up here in your kind of in-browser code editor, you can change your spaces, or your indent mode, I should say. And so I've got mine set to 2 spaces. That tends to work best with GitHub Actions. It may be set to tabs by default. If you're running into issues there, you may try switching your indent mode to 2 spaces, so that when you hit tab, it's just going 2 spaces instead of an actual tab. Okay, so if everything looks good there, you can go ahead and commit that. And I'm going to give a commit message. In this case, I'm committing directly to the master branch, which is also something you normally wouldn't do, but as we're doing it ourselves, normally you would create a branch, you would have a code review, you would have somebody else approve that, and then you would merge it. In this case, we're committing directly to the master branch. And again, I go into that a little bit more detail in the course, the DevSecOps Pro course. Okay, so now we've got that in our directory, so GitHub Workflows directory. If I go to my Actions tab, you'll actually see this running. So if you click on that, you'll see build-SBOM is running. If I click on that again, you can actually see the specific things happening. So remember, we named these, so that's what you're seeing here in these collapsible items here is what's happening. Create output dir, checkout code. We gave those names. And so what it's doing, first it sets up the job. You can see it's provisioning a runner. It's telling it which operating system. So in this case, Ubuntu latest is 24.04.3, the LTS release. It's going to go out and continue to do what it needs to do. So it's downloading those repository or those actions. Remember, I said that version is correlates to a specific SHA hash. So here's that SHA hash. So if I were to go in there and add those, so instead of saying action/checkout at v4, I would say at the SHA hash. That's going to always pull that commit every time. And again, you should review that. So check out the YouTube video I did on that if you want more details. Goes through and it checks out the code. So this is moving all of the code from that repository into your local directory there on that GitHub runner. We created the output directory, and now it's going through and it's doing all of the things that CDXGen does to create that repository. So it looks like it's just about completed. So it finishes that SBOM generation, and then it uploads that artifact to GitHub, and then it is completed. So now as we go back to that flow or that workflow, you see it created. It took about minute 57 seconds. And if I click into that now, you'll see that it has these artifacts, and you can download those. So that's what we wanted to complete and create. So now we've generated those SBOM files. Now, if you remember, I added that one small change. Let's go back and fix that. So I'm going to edit that, and now that we've got it to run once, I can take out this no install deps. So this is going to force it to install all of the npm repository, or all the npm packages that are required for that. So I'll go ahead and commit that. And this one's going to take a lot longer to run. This will take about 8 minutes in my testing. So see, that's running now. But we've got that SBOM that we can run, that we can check out. So I actually generated that beforehand so that I could show you this without having to wait for it to run for 8 minutes. And so what you would do, again, OSV Scanner, it's pretty simple to install, but OSV Scanner can do several things. You can point it at your repository and it'll scan and look for vulnerabilities within the packages that you're using. It'll look at the package manifests and it'll enumerate all the packages you're using and then tell you if there's vulnerabilities in there. So that's pointing it at your repository. You can also point it to a Docker image or a container image, I should say, and it'll scan that container image for vulnerabilities, vulnerable packages that are used in that container. You can also have it look for licenses, licenses that you are not allowed to use or that you are choosing not to use because of restrictions in those licenses that make it so you can't use them in your product. And then finally, what we're doing right now is we can point it at an SBOM. So I've downloaded this SBOM. It comes down in a zip archive. I unzip that and I get this sbom.cdx.json file. So if I run OSV-scanner with the SBOM flag and then point it at my SBOM file, my JSON file, it'll take just a few seconds. You can see it found almost 2,461 packages, and it found 34 packages, had vulnerabilities in them, total of 58 vulnerabilities, 5 critical, 21 high, 23 medium, 1 low, and 8 unknown. So it'll go through and it'll give you the information on those specific issues. You know, what are the vulnerabilities? What package is introducing those vulnerabilities? and what version are you at, what version do you need to upgrade to. Now this is another thing I'm not going to go into here. This is another thing I kind of talk about in the course. You can actually use OSV Scanner to update these things. And so it will attempt to update it as long as there aren't breaking changes. So what do I mean by breaking changes? So for instance, you've got this one base64 URL. You're currently at version 0.0.6 and the fixed version is 3.0.0. So there's this versioning scheme where the rightmost decimal point is a patch level or a bug fix. So this is things like, we need to update this small thing. This is fully backward compatible. Just update this patch. Just apply this patch. The next one is a minor version. And these are typically also backward compatible. Sometimes there's more substantive changes there that you may need to know about, but they're also fairly safe. I would say, on the upgrade risk scale, these are probably moderate risk. You probably want to be aware of what's being changed there, but there's a good chance that you'll be able to upgrade safely. And then the leftmost digit is the major version. So these are major releases. Oftentimes there are breaking changes in those that are not backward compatible, that are not API compatible with previous versions. And so you probably have to make some changes in your code in order to make that upgrade safely. So in this first case, or the second case, base64 URL package, we're going from one of the very earliest releases, 0.0.6, to three major version upgrades. We're going from version 0 to version 3. There are likely going to be a lot of changes in there that may break, that are not backward compatible. And so you've got to make some changes in your code if you're using those things that changed. And so in this case, chances are OSV Scanner is going to look at that and say, I can't do anything with this. There are breaking changes here. You're going to have to do this manually. On the other hand, let's see if we've got an example of one that is not as big of a deal. Right here, Minimatch. So we're going from 3.0.4 to 3.0.5. So again, that's a bug fix change. That's going, a very minimal change. That should be very safe. The upgrade risk on that is very low. But this kind of it speaks to why software supply chain can be so difficult. And I spoke about this a little bit in the last webinar. There aren't really good tools to help you today that will help you go from something like 0.0.6 to 3.0.0. It's actually something I'm working on in a different project called Lunar, which I'm not going to go into today, but a project that we're using to try to solve that issue. So this is something that's near and dear to me. Okay, so let's go back. You can see that is still running. We've already seen what it pulls out, and I suspect it's going to go another 3 minutes or so. So it's throwing all sorts of errors here. Okay, so this is another thing I'll point out. If you run into issues, this is where you're going to find that log. You're going to find the issues here. It's usually pretty verbose. Whenever I've run into an issue with these things, typically you find it here. And although I don't have it today to show you, when I was working on this workflow recently, I ran into some challenges with how the Docker image was run, the permissions. It wasn't able to create the files it needed to create. And so this is where I found that information and how I fixed it. And so if you run into issues, this is where you go. And you can usually search and find some pretty good details that will help you through that. Okay, so at this point, we have completed everything that we set out to do in this kind of live build. We've created the automated workflow. Again, if you want a link to that, I think that should already be in the chat. If not, I'll ask my team to drop that in there. Yes, it's there already, just confirmed. And so if you want to go ahead and generate that yourself, you can grab that configuration file, that YAML file that we created together. It produced the artifact. You saw where you can download that, how you can analyze it using something like OSV Scanner. And there are several other open source tools. We talked about them briefly in the last webinar, one called Guac, one called Dependency Tracker, and those are free and open source tools that you can use today. Okay, so let's go ahead and kind of wrap this up. Okay, so the path forward, how do we scale with this? So this is really, I think this is why this matters so much. This is the foundation for what you're going to do, right? Whenever you build automation in GitHub, whether it's for kicking off, static analysis or software composition analysis scans, dynamic scans, SBOM scans, all of those things, you can use this same strategy to do that. Same components, just different, leveraged in different ways. You now kind of have the foundation to go out and build those things, the foundational level understanding. And there's, so all of the 4 layers that we talked about in the last webinar, you're going to build it using this structure, this framework. And it's really not that difficult once you dig into it. Again, my course, we walk through all 4 of these layers and more, where you get walked through step-by-step, kind of hand-holding, where you can do it yourself. So that's, I feel like that is, in my opinion, the most important part about building for the future. It's again, the AI-driven development landscape. It's resulting in more code deployed faster. Oftentimes, the people deploying the code don't understand it. They don't comprehend what they're pushing out there for whatever reason, either because pure laziness, they don't have time, they just trust the AI to do it right, but it's resulting in more vulnerabilities. In that very first webinar, we talked about it's making developers something along the order of like 20% more efficient, and the code that it's generating something along the order of 46% or something like that of that code has vulnerabilities in it. And so we're seeing vulnerabilities churned out faster and faster. And so if you're in an AppSec team or in a security program that's still using manual processes, you're going to fall further and further behind. So that's my takeaway. And I hope this doesn't feel like doom and gloom. My takeaway is this is actually a good thing. I don't see AI making security engineers obsolete. It's making those manual processes obsolete. And so if you're still relying on those for everything you do, start carving out some time to figure out how to automate those things and make them run, whether or not you kick them off. Because let's face it, the things that we automate, that's the boring stuff. That's the stuff that nobody wants to do. And so when it gets skipped, it's because nobody's thinking about it. Nobody wants to do that. So let's automate the boring stuff so that we can do more of the fun things, the things that really matter, the things where your judgment, your skills, your expertise can't be replaced by AI, right? And so to me, that's the opportunity with those skills that you gain by automating these things, by building those automation workflows. You can become that engineer who helps organizations find the sanity and the chaos that's being created by all of the AI uncertainty. And I'm by no means an AI naysayer. I think I'm cautiously optimistic. I think it's here. I think it's going to generate some benefits, and it's also going to create a lot of problems in the process. And so my invitation to you is to become that engineer who can help organizations kind of shepherd their tech programs through this uncertainty and build the automated workflows that'll help them do the right things from a security perspective while they're building code faster and churning out more vulnerabilities in the process. Okay, so really quickly, I know some of you are not going to be content with just scratching the surface of this. We covered a lot in this webinar and then in the last 2, but there's still a lot to learn, right? And so some of you are going to want to go deeper, and some of you are going to want to really dive in and understand and master this. And so that's what my DevSecOps Pro class is all about. It's to help you learn how to build these things from scratch. And again, it goes back to when I was learning this stuff, the training options were super expensive, and they were good, but I wanted to create something that was on par with those training courses quality-wise, but affordable for people who were self-funded and needed to fund this themselves. So that's what I set out to create. I also found that a lot of the DevSecOps courses, they get kind of hand wavy, right? They get to the labs, and it's either in browser, which is you can only make it so good. At a certain point, it's not going to be high fidelity. Or they get to a certain point and they start hand waving things. They don't talk about the details that you need to build on the back end to make all of this work. For instance, if you're running a dynamic scan, how do you deploy that? How do you give yourselves permissions to scan that without exposing it to the public internet? And so that's something that we dive into. So my Black Friday bonus, it launches on Friday. It's limited time. It's going to run Friday to Monday, Friday morning to Monday night. And it's 30% off. So this is the only time that I expect to run this until probably next Black Friday. And so it drops it down. It's already under $200, but you're getting substantially more off. It's only $137 for a year of access. You get 16 hands-on labs where we go through and build, just like we just did. I walk you through building those labs. It goes broader and deeper into some of these things. There's 32 lessons or tutorials that are bite-sized. They're meant to be short, something that you can watch on a lunch break or after work or whatever. And then I also give you 15 ready-to-use templates. So we're starting a new cohort in January. I think it's January 7th, if I recall correctly. And during that cohort, we meet weekly for 6 weeks. And these are live coaching calls. Incidentally, outside of the cohorts, I continue to run coaching calls on a bi-weekly basis. But during the cohort, they're every week. And we walk through this stuff together. So you watch the lessons, you do the labs, and then we get together, answer your questions, we work through any problems you have. I've also been known to bring in guest speakers that give some additional insight on some of these things. And once you're in, you can join any of these cohorts. So I run 4 cohorts a year, 1 every quarter. And so with this, you can theoretically join 4 cohorts. You can attend all of these coaching calls. You can abuse or use this any way you want. This is your opportunity to come and ask questions to get my coaching or whatever you want. There's a private community that goes along with this where you can ask questions and get feedback from other students as well. And then finally, you build a portfolio. So this is one of the reasons that I think doing actual labs is so important. So if you do a training session where you're doing this kind of in a contrived in-browser lab, you come away with the understanding, right? You've done some hands-on work, but you don't really have much to show for it. If you go through these labs in this course, at the end of this, you have a portfolio built out in your private GitHub repository, or not your private, in your personal GitHub account that you can then show to people. So if you're up for a promotion or you're interviewing for a job, you can actually show an interviewer what you've built, and it's verifiable because you can go and check the commit logs and see that your account is the one that created that. And so it's a really great way to demonstrate what you're able to build for your current or future organizations. And then finally, the bonus for this cohort only, this is part of the Black Friday special. In addition to the discount of pricing, I'm throwing in 2 additional coaching calls. And this is AI AppSec. So this is how I've used AI AppSec or AI tools in my AppSec work. And so specifically, I'm going to dive into how I've used Claude Code to do some things that typically are really heavy on the manual effort side. So, and I'm really excited about this. This is something I've spent a few months on, just figuring out how can I use AI coding tools to do AppSec work. And it's really exciting because these tools are able to gather context on the code and do things that, again, have typically taken a long time to build, lots of manual effort. Okay, so that's my offer. The link is up here on the screen if you want to join that. Again, the offer doesn't open up until Friday morning, so you can join up. You can sign up to be notified when it goes live. But this is where it's going to happen. Okay, so with that, I will go ahead and open it up to any questions. I'm going to go ahead and scroll back and see if anything came in. All right. Looks like no questions in the chat window. Just go ahead and, if you've got anything you want to ask, just go ahead and drop it in the chat window and I'll answer them. Looks like we've got people joining from Texas and Hawaii, so that's cool. Last time we had Phoenix and Canada, so we kind of went north to south, and today we're going west to Midwest, maybe. All right. So I'm going to stick around for a few more minutes, just in case anybody has any questions, in case anybody's typing something in the chat window right now. Here to help out. And again, if you register, you'll get the replay links, you'll get the slide deck, you'll get the certificate of completion, all that stuff. And I just want to take a moment to thank you, especially if you've been with us for the entire series, all 3 webinars. Appreciate it. I really hope you've learned what you set out to learn. It's been fun for me. These are things that I'm super passionate about, and I feel like it's important. It's important not only for you that are here, but for everybody to understand the way the kind of the development world is changing, how we prepare for that, how we improve what we've been doing by leveraging more automation and building those things in, so that the right things happen at the right time, whether we're there to push the button or not. All right. Well, with that, I will wrap up. And again, thank you very much. If you celebrate, have a very happy Thanksgiving. And if you are manning the forts during Black Friday and Cyber Monday, and especially if you're in the retail space, my sincere, heartfelt condolences go out to you. I hope it's quiet. I hope things go well. And I hope you have a wonderful holiday season.